So much achievement that I think he is the world record in many things. So, however, as by duty and by privilege to introduce him, Professor Bhim Singh has received his BE Electrical from the University of Roorkee. Now it is IIT Roorkee, India, in 1977, and his MTech Power Apparatus System and PhD from Indian Institute of Technology, Delhi, in 1979 and 1983, respectively. In 1983, he joined the Department of Electrical Engineering, University of Roorkee, as a lecturer. He became a reader there in 1988. In December 1990, he joined the Department of Electrical Engineering, IIT Delhi, India, as an assistant professor, where he has become an associate professor in 1994 and a professor in 1997. He has been ABB chair professor from September 2007 to September 2012. He has also been CA chair professor from October 2012 to September 2017. He has been head of the Department of Electrical Engineering at IIT Delhi from July 2014 and to August 2016. He has been the Dean Academics at IIT Delhi from August 2016 to August 2019. He has been J.C. Bose Fellow of DST, Government of India, from December 2015 to June 2021. Professor Singh is currently serving as an emeritus professor and SCRB National Science Chair at IIT Delhi since July 2021. Professor Singh is a chairman of BOG Sardar Vallabhbhai National Institute of Technology, Surat, since 25th August July 2023 for 3 years. Professor Singh is a fellow of the Indian National Academy of Engineers, the Indian National Science Academy, the National Academy of Science India, the Indian Academy of Science India, the World Academy of Science, Institute of Electrical and Electronics Engineering, the Institute of Engineering and Technology, Institute of Engineers India, and Institute of Electronics and Telecommunication Engineering, and a live member of the Indian Society for Technical Education, System Society of India, and National Institute of Quality and Reliability. He has published 1,343 research papers in journals and more than 1,852 papers in conferences. Professor Singh has guided 138 PhD dissertations and 183 ME, MTech, MS theses. He has been 76 granted patents and 33 filed patents. He has executed more than 90 sponsored and consultancy projects. He has co-authored a textbook on power quality problem and mitigation techniques published by John Valley and Sons in 2015. Professor Singh is a recipient of Rashtriya Vigyan Puruskar Vigyan Shri by the President of India for the year 2024. He is also a recipient of the IIT Roorkee Distinguished Alumni Award for the year 2002-03 and the Goel Prize in the field of Applied Science, Kshetra University for the year 2021 to 2022. Professor Singh has received Khosla National Research Award of IIT Roorkee in year 2013. He is a recipient of the Shri Om Prakash Bhasin Award 2014 in the field of engineering including energy and aerospace. Professor Singh has received IEEE PEC Nari Hingorani Custom Power Award 2017. He is also a recipient of Faculty Search Award as the most outstanding researcher in the field of engineering 2018 of Career 360 India. He has received inaugural Faculty Lifetime Research Award 2018 for the overall research contribution at IIT Delhi. He is recipient of IEEE IAS Outstanding Educator Mentor Award 2020. Professor Singh is also the recipient of IANA Outstanding Teaching Award 2020. He is also a recipient of International Kalpana Chawla Solar Award 2020, hosted by International Solar Alliance for the outstanding contribution in the field of solar energy, particularly for working toward developing solutions in the solar energy sector to help create a sustainable and low carbon world for generations to come. Professor Singh is a faculty mentor of the following successful startups: MS Cotton Private Limited, MS Hyproax Energy Private Limited, MS Intelligent Technology Private Limited, MS Technics Private Limited, and many more. His area of interest include solar power grid interface system, microgrid power quality monitoring and mitigation, solar PV water pumping system, improved power quality, AC/DC converters, power electronics, electrical machines, drive and electrical vector. Now I request Professor Bhim Singh sir to deliver his lecture.
Well, good afternoon to you. I think we are getting delayed. I don't know how much time the organizer will give to me. Typically. Well, anyhow, let's start, and I don't know if time clearly don't permit, so please, I think then the sessions here can tell me when I have to stop. Okay? No problem. Well, it was very difficult on the phone to tell Professor Ramnivas Mahiya, sir, give the topic. So he was pushing 2-3 times, and then I thought what is the theme of the conference. So he told renewable energy is one. Okay, then you can consider probably solar. And he wanted more specific, then I have to send even a 1-page write-up also. And so I thought this may be one of the area in which we are working probably last 15 to 20 years, and might have graduated for in all solar probably more than 25 PhD students. And as far as publication, in IEEE Explore, I think we are number 1 in the world on this solar. If you put the solar PV, you can just go to the IEEE Explore and look into that. I thought this should be a little justified topic. Probably to speak about. And well, we are not the solar man, we are electrical engineers. Okay, so you can understand, especially electrical also, especially power electronics, but probably Professor Suryavanshi is also there. So we work in the project, a joint custodian project also one in that typically, and probably we have been many such projects for that. So well, usually the problem is I belong to very, you can call it village family, farmer family, very difficult to accept very quickly anything in life. Or you can call it very passive starter for everything, like for the research also, as well as for other things, not so quickly to adopt. But once we accept it, we made a point that we don't want to be number 2 in the world. In whatever technology we put the hand, we have been number 1 in the world. We don't compare in our own country or institute like that. So that's the trend I put with my student, that you have to do something different, what it has been done like. And why we won't tap into the solar? Because solar energy use almost double the converter. Power electronics converter I am talking about. If you use the double the converter, so I was not keen, why? So problem started from there. When people start talking about on solar inverter around 2005 or around that the solar inverter really create the power quality problem to the grid. And I really thought there is something wrong with this. So I asked my probably student to look into what is the solar inverter. Then they studied and just explained me, sir, this is the kind of inverter. This is the inverter we have been operating probably for last 25 years for power quality improvement. We put the same inverter for power quality improvement into the grid, and we are not successful because technology was very costly. In India especially, neither the inverter devices are manufactured, nor the inverter are manufactured, nor the control DSP is manufactured, nor the sensor are manufactured. So then it's a very costly to employ as a typically power quality device like active filter, D-STATCOM kind of thing. We really people named it different way. And here we have an inverter already. So we don't have to invest any cost into it. Only we have to modify the control. Of it. To use this inverter for 24 hours. Because solar generation is not full all the time in the day also. No? So an inverter rating is usually selected 120% of the rating for which we are designing. And we design for peak power. Peak power is never in the solar. So you have around 80 to 85% generation maximum. So 15 to 20% rating that and 30% rating that. So this 35%, 40% rating we can use even the day, and in the night this is 120% rating available for the inverter for the cause for which we are doing research for 25 years. Okay, so it's a, and no need to touch the hardware, only to modify the control. And I told to my student, the control is more tough. You know, we are not supposed to improve only the quality of the currents, which really have probably the problem of harmonics, reactive power, negative sequence or unbalanced currents, neutral currents. This is not the problem only here in India. India problem is that where you are connecting this system, that also have a pollution. Voltage is also polluted. So we have to use the control for filtering the voltage also in control algorithm. So in place of, in the world, if you go to Europe, if you go to North America, they put the algorithm only for current, but here we have to put the algorithm for voltage. It means whatever the algorithm we develop, it never will fail in the world. And that probably IEEE, at least for transaction paper, people recognize us. So in place of putting one algorithm, we have to put 3 to 4 algorithms into it. And you can understand, our students have a good strength of mathematics. Okay, so they can do much better. So I didn't ask my student also to develop much hardware. I told I will provide the entire hardware to you in the lab, and you have to put only control for it and modify the control as it may be applicable directly into the field light. So with that, we go to typically for solar rooftop. First, as a SERI project, Solar Energy Research and Initiative, I think of, we gone to 60 lakh, but they gave us, for 3 years, they gave 1 crore for 4 years. We completed it, we gone to another project for 3 crore, but they gave 2.5 crore because 50 lakh was the overhead. They say we don't give overhead, we'll give you only the overhead of probably 5 lakhs or something like that. So we will reduce you by 55 lakhs. Well, you are giving something, you are not taking from anything from me, okay? That's good. So this was the initially soap project, but later on we gone like Uttara Viskar 4.5 crore project, then 7 crore in probably 4 crore and 3 crore into custodian project, then probably 8 crore in another custodian project. You can understand the total funding might be coming around 20 crore. In 20 crore of government money you have to do something. And by philosophy is at least in 1 crore, 1 PhD should come out. I haven't 1 lakh, 1 research transaction paper should come out. So once so much start funding is coming, my formula getting failed. Like I have to find out a lot of people, but certainly there is a saturation. How many students you can handle at a time? Not more than 70, 80 or 90. I told we have to pick a limit here, okay? That's not matter. We have to spread, not to really go for the field or something. So that's something is gone. So I would like to explain probably not more than 2-3 applications in brief about this solar. And I hope thank you for who already mentioned about it. So can you think about why this energy is coming, like solar is coming? Like you can think about Haryana government put a tender in 2010 with a cost of 18 rupee per unit. And the company have deposited the earnest money 10 lakh and they run away. Because the government put such a restriction, I mean, even the government was apprehension and people were also apprehension, they will generate, because cost of electricity was 18 rupee per unit and diesel was 14 rupee per unit. So there was apprehension that people will generate by DG set and claim for solar. But you can, I mean, in 3 years the price from 18 rupee is going to like a 6.47 rupees per unit. And you can understand probably it is 2013 to probably 2020. It's 8 years it reduced to 1/3 further. 6.47 rupees to it came to 1.99. And probably my friend from North America, he mentioned it, in Middle East it's already 1 rupee per unit. You know why? Because the Middle East people put a very mass development of solar. Why? Because they have a lot of air conditioning load. They have a lot of oil. But you can understand the oil, somebody will take from them. And you have seen probably how many wars have been in Middle East. The reason being oil have been Saddam was hanged for oil only. And you have seen what is happening to typically to Russia, what is happening to even to Iran. All it is a problem with the oil because they have oil. And that's why the people are enemy for them. They have created those, and fortunately we are lucky we don't have oil too much that we can export and we can make the people really the enemy of us. But the solar you generate locally and use locally. And that's the reason Middle East people also, oil companies especially thought it, let's go to the solar. It will be our own energy. Nobody will like to take the panel from the roof because they themselves manufacturing the panel. Whether it is North America or Europe or China. So nobody will like to. It's something like education. No? Nobody will take from you. They may kill you, but they can't take your education from you. So it's exactly the solar is in the same way. If you are putting your rooftop, nobody will take it from there. No? So the solar have been such a, you can call it interesting, and believe or not, in next 5 years it has to be 1 rupee per unit. What is the indication? We are doing some project with a relatively big industry like Adani. They say, sir, Chinese have manufactured so many panels, they have already brought the cost to 12 rupees per watt. 3 years back, when this was 1.99 rupees per unit, panel was 32 rupees per watt. Now same panel is 12 rupees per watt. So if panel cost reduced to 1/3, electricity cost have to reduce it, because major cost was only solar panels. So there are indications in the future that it will certainly have to go to half, because some country it is already half, because they already have a mass deployment. We are not having so much deployment as our requirement like. Also, but government is also very concerned that we should not kill our own industry by taking all the panels from outside. So there is highly people are confused in the process like. But no doubt, government have to later out think about that we need such a mass deployment. Does not matter from where we take it, we manufacture it, we take from somewhere, but we have to really install it, no? Because there is a need for such a large population, 140 crore, there is a huge need of energy. Okay, especially. And another energy requirement is coming, I mentioned in my morning talk also, is the electric vehicle. Transport system in the world consume around 50% of total energy. And that 50% also, if your own country want to bring on electric vehicle, means you need the electrical energy. So the entire pressure will be coming to electrical energy which produces by cheapest way. Earlier it had been the hydro, but you can understand the hydro. I talked to NTPC, I was in board of independent director in NTPC, I told, why don't go to hydro? They say, sir, you already seen the experiment of Tapoban. What happened in typically, and moreover, the hydro takes around 25 years to build up a plant. One generation goes, number one. Number two, if there is some sadhu is there, I will say Sarkari sadhu, then project may be delayed by 25 more years and cost of the project may be 10 times. And exactly it happens, you will not believe, the cost of electricity produced by TD Ram is now 6 rupees per unit. It's a confidential document. I really saw somewhere 6 rupees per unit, where it should be 60 paisa per unit by hydro. So, this is one of the energy, only our challenge is, because this is available intermittent way in the daytime. So how to really use more effectively? There are plenty of applications where you may not need the storage, and that's the challenge to the let's say researcher or the developer of this technology like now. But you cannot deny the technology of electricity is so cheap. If it is going to 1 rupee per unit, you can probably put the storage also of 1 per unit. People will not mind. And storage also probably half the world is working on the storage now. Because storage cannot necessarily be used in this renewable. Storage is supposed to use in even another technology like electric vehicle. So cost of storage, the information is there. In China, 50 institutes are working on the battery. Typically, and India also put a very big money, around 1,000 crore on the battery development or research in the battery. And I think one guy of typically who has a startup, he says, cost of lithium-ion battery probably maybe going to equivalent to a lead-acid battery in next 5 years. Where is the typically money, the research, everybody, corruption, research, everything goes to that. Nobody thought of other way around. So what I mean, you cannot deny the technology, it has to, you need the electricity, you have to go big way on that. So this is why we have to go for. Wind also got reduced. In wind also have been, the revolution from probably 6 rupees has gone to 3 rupees. But I can tell you 10 years back also we were having 40 gigawatt of wind. And today we have only 50 gigawatt only wind. Now again it's accelerated, but wind is a major problem. We can't put the wind turbine into the sea, because our sea are volatile, not like North America or Europe. Their sea or lake are very calm. We can put only on coastal area, and that's limited only, number one. Number two, there is a problem that you have to transmit that power. So transmission network is another bottleneck, but here you can put on rooftop. And you can use locally there. Wherever it's generated, you use it there only. So you don't have to put any transmission system. My power system friend will get annoyed from me. Here maybe major people will be a power system will say, probably may not use this energy transmission system at all. If you have an energy storage, there is no need of transmission system, distribution system, maybe enough if it is required for this energy, especially solar energy, what I mean also. So that's the reason why you have to go to the technology. There is a heavy requirement and heavy And when you require a mass, the cost price goes down like anything. And that's the thing which is happening around the world with this technology like also. Well, this is, I can skip the slide, and why renewable, that also I can skip it, because there is pollution and cost is also one. People understand the money, especially engineer technology understand the money, okay, and which I already mentioned about it. Okay, this is not only responsible that electricity generation will be cheaper, but the other technology like electric vehicle also depends on electricity, and that's going to be further cheaper. I mean, like, so it means you need the energy for that also. So this is the one of the simplest and cost-effective and clean energy from there. Like, so you have a lot of potential, and fortunately we are in good map of solar map from 4 unit to 7 unit per kilowatt. I hope you understand. A 1 kilowatt panel can generate 4 unit to 7 unit, 4 kilowatt hour to 7 kilowatt hour in a day, depends on which portion of India you are. Perhaps even in daily it goes even 5.5 units per kilowatt of panel installation in a day. So that's not typically bad, it's a reasonably good like in that day. So we can go ahead without much problem typically. So anyhow, these are the some of the typically installation, I mean around the world and typically in India. These are the some of the application you can think about, standalone application. I mean like a lighting system, then these are major application in India, which government is India forcing it. We give the subsidy to the diesel on the name of farmers. I mean, diesel is cheaper, like, compared to the petrol. But diesel have a more calorific value, if you consider compared to petrol, only because of pollution. But the major reason is, who is the largest consumer of diesel in India? Is the railway. And second largest is the telecom tower. You may forget your meal, but you will not forget your mobile call. I hope you will agree with me. So it means there is a heavy requirement. But Government of India already warned the telecom tower operator that you have to reduce the diesel consumption. We cannot eliminate completely the diesel set. The reason being somewhere electricity is not there, but telecom tower is there. And even if it is a telecom, electricity is there, but it's not reliable. We want the your mobile system a reliable telecom tower operating telecom network like. So it means they say, why don't put the solar panel on every telecom tower? And you can understand this becomes almost 5.5 lakh microgrid with the solar integration into it. They have a DG set, they might have a grid integration as well as the solar integration into it. It's not so easy to build wind, because wind is not every place. Okay? But solar is at every place. Like. So that's the application you can take about 5.5 lakh solar panel installation as a kind of microgrid along with the amalgamated with the DG set as well as maybe with the storage also. Like. Then water pumping. This technology we tried it in 92 to 97, wind as well as solar, in the government of Mr. Narasimha Rao government like. But I can tell you there is a right time of launching the technology. I mean, technology is available, like launching the technology, like if I give you an example in EV, 96, GM launching California, 2 year bank, company become almost bankrupt. Okay, but after 1 decade of 96, in 2006, Elon Musk put in the same Silicon Valley, Elon Musk put the electric vehicle. And you know who he is now. He is the richest person of the world. Very classified car. He made a car that, okay, not to sell in North America less than 1 crore. A lot of people are there who can spend 1 crore. And still the Tesla in North America is still considered like a mobile phone in 2002. I don't know how many you might have observed a mobile phone in 2002. Who bought a mobile in 2002, he always the guy was keeping mobile in hand. As a prestige symbol that I have a mobile. Because that time receiving a call was 16 rupees per minute. So 16 rupees per call was the receiving charges. So it was a prestige symbol. That time the kind of. So same way, now Tesla in typically North America is still considered as a prestige symbol. I have a Tesla car. Okay? And now they already launched for the taxi also. Driverless taxi. My son yesterday was telling me, here in Atlanta, they have now a taxi which does not have a driver. Okay, you can ride it. You give your entire money and all that. The way we book the way, you can book that. You can put from where to where to where. You sit it, there is no driver. And this car of Tesla, which work as a way, will drop you at the right place where you want to go. So technology has been too advanced, what I mean. So that is the launching right time of the technology, you can understand. So same way solar, and we are trying in 92. I have gone to Central Electronics Limited also to see the solar water pumping system. And that time, I mean, like, I don't know, some data is there, it's not there. I'll probably maybe later on slide. That time we install around probably 3,000 pumps, like. And now we might have probably pump will be going. We have been associated with this technology with the industry called Shakti Pump. We did the one project with the consultancy around 13 lakh with them. Then they gave a 1.1 crore to us again for as a sub project which were having 4.5 crore. We had another project of 60 lakh. I graduated 10 PhD student in this. And now in last 5 years, Shakti Pump have their stock going to be 49 times. Only because of this technology. Last 2 years back, profit was 1 crore, last year profit was 93 crore, this year profit is 550 crore. I get information because I am a independent director, but this is all in public now, typically. And they have a 2,000 crore worth of order. We feel that we have been associated to get develop this technology, but we didn't get anything. At the end, my student is CTO of one of their industry. Only the bonus was I am independent director with them. And they say probably we have a meeting every 2 months. They give 2 lakh to me. So they say, sir, don't worry, up to age of 75, we will give you 1 lakh per month. That's the bonus for 5 years, you can understand. Typically only that. But still their CMD says that you are the person who is able to force us to develop this technology in the industry. Otherwise, it got developed by ABB. 3 horsepower controller in 28,000. He said 75,000 I have to give into field. And cost day by day will decreasing. Then they go to Chinese, it was 16,000 to be. And they brought 10 pieces. Within a couple of months, all 10 pieces came back. Then they decided we have to develop in the industry. My one master student, we did that consultancy, he gave, but they were not taken with the technology. Who will translate the technology into the product? Then they asked what to do. Now take a person of industry who had been in industry of the type for 10 years or 15 years. They called a person who wanted to come to Indore from Bangalore, and one of my students, they made a group. In 3 years, they put the plant of 15 crore. And the guy who was really from industry gone out, now we are the only startup of 100 crore. I mean, for something else, like, but my student is still with the same industry, to whom they are giving good salary of 70 lakh and 12,000 shares, which will become in 2028 around 2 crore. And you put the 2 crore, if you put in his father name, in bank it will be senior citizen will get around 7.5% interest. So it is a more than my pension. Money will be with him till the parents alive, they will get a whole life pension. Okay? And this is hardly 4-5 years, I mean around 7-8 years job of him. Only as a bonus. Okay? Salary is apart from, okay? And that's getting increased. So you can think about how the technology goes. This is a homegrown technology which I am giving an example, and we have been associated. And he says you are the person to really responsible to get it develop the technology with us. Every board meeting you always talk about that only. They are putting 1,000 crore plant of solar backward to solar module. They say that is nothing a technology. Packaging will come the plant, I will put 20 engineers and they will run the plant. There is no R&D into it. Like. But this was the really R&D a tough task that we have to develop in the industry and cost effective too, typically. So that's something we did. I mean about graduating around, that is a satisfaction that around graduating around a 10 PhD student, like maybe some master student. Of course, we might have around 200 publications out of it, where there will have been some master students, then interns, lot of people work on that. Like, Then another typically lighting system, then your charging infrastructure. These are some of the applications. Then satellite. I learned really maximum power tracking from this. One of my students, which I was mentioning, Professor Raghav, who has been with us, unfortunately no more. He did stepper motor for positioning the solar panel mechanical maximum power tracking for satellite. That I learned what is mechanical maximum power tracking. And to a mechanical engineer, I have gone to industry to make him convince there is electrical maximum power tracking. It took me half an hour. It's like a tree of orange. If you don't pick up the orange, it will fall down and go away. That's the example I have to give him. So you have to extract from electronics converter the power from the solar, otherwise the solar panel is already there on the roof in the sunlight. Till you don't extract the power, it will not be like that. It is like kind of thing. This is on rooftop probably, and you can see even a typically military man is putting on his bag to have this kind of solar generation typically like or so. So then transport system like railway, you have seen on the train Then the metro stations, including people start putting the trucks, even rickshaw, e-rickshaw, I mean typically. So I asked my student to have a passive estimate how much we can probably generate in India. So we took a passive estimate and it comes around 2566, which is 100 gigawatt is at the moment, and you can say how many times it is, like more than 26 times. Like. So that is the potential with very passive estimation. Typically in kind of different application we think about, around 13 applications we consider it of this use of solar in India. So which can be even, you can, at the moment we have a 500 gigawatt. This is around more than 5 times what we have total generation. And say 26 or 27 times what we have the solar today. And if we really use whole in next 5 years, of course the country can be developed only when we have electricity generation. It's directly related. Transport system is also related to this. Your even life standard depends on electricity and depends on it. Like, and this is the cheapest way of generating electricity. So you cannot deny the technology like coming up. Well, these people are coming a different industry in this way. This is the industry called Enphase. They are developing such system, a charger into the home, a battery into there, a small DC set into there, solar panel into it, and you know, the stock of this, the startup was in California in 2006, up to 2009, their stock was only $6. And 2019 to 2021, you know, their stock has gone to $176. I mean, that's really called a startup. I mean, like suddenly they are able to, and they have a very less number of 4 or 5 products, not much more, or portable solar generation with the microgrid like DG set and battery. For portable means for electric vehicles, as well as for use for many purposes, and in home also, like, so kind of. So anyhow, these are the some of the, I hope you recognize this person?
Yes, yes.
Oh, good. If you recognize, he was the visionary, it was the first installation on canal in Gujarat. You know, when your star are very positive, how people translate it. This was not in the news in this manner, that our that time Chief Minister of Gujarat really inaugurated it. In the media it came, so much water will not be evaporated from the canal. You know, the other benefits, the side benefits were more reported by the reporter in the newspaper in place of really having electricity generation from canal. So they put as a first typical and another. Bhavri Devi will not be put now into, after murder, into the canal, where it is surveillance here. Intelligence surveillance here, if you temper little bit, the alarm will go and complete security system will be really alarmed, something has come to. So you cannot make a thief of it, or you cannot touch the light. And this is a good picnic place to visit. So you can understand how we will be changing the scene as a altogether different means and electricity generation like. This is typically, one of the largest plant in Karnataka. There are plenty. This is a plant in Rajasthan, so I think electricity generation, and this is in rooftop, largest rooftop of 7.52 megawatt in Dera Vyas, where a lot of people, you might have heard about the satsang, like people live in the Agra, same way there is another kind of living, kind of a complex in Vyas, Dera Vyas in Punjab. So they have a rooftop of 7.52 megawatt. That was one of the largest around decade before when they installed it, like also. Now, what is the latest trend? You have a string inverter. I was not knowing what is the string inverter, that you keep the panel in series and put to a single inverter and put to the grid. Then you have a micro inverter. Inverter is put with every modules and then put to the grid. And then you have a power optimizer. With each panel you put a separate module and then central inverter. Like. So these were the technology into the field. Are you able to follow typically? So we look into what is this technology like. So I asked my student to work about, these are the advantages, anyhow I can skip it. Okay. So when we start working only looking at this inverter because it's not properly used, the funding which we got it, I told to funding agency, if 20 experts are sitting and they were ready to grill me like anything. I tell I will make a power electronics cost zero. There is a physical power electronics converter into with the cost of 20%. I will make it zero. Who is the best doctor? It give a medicine minimum. I will follow like. So I say I will recover the cost of our converters from some other inherent application of it, which I mentioned it, work using this solar inverter for 24 hours in distribution system for improving the power quality. Are we to follow? So power electronics cost I will recover that, and maybe payback will also reduce it. If it from 5 years to 4 years like. That's what people understand, and I'm not going to add any component, whatever it is there, only will modify the control. With that only, we started working, and we classified into different categories. Probably in academic world, we have to give a different option. Today, industry may accept something, after 10 years, industry may accept something. I asked some of my students to work on double stage. You understand double stage. Talk about single stage means solar panel is directly connected to the inverter, and inverter is putting to the grid or maybe application. This we call it single stage. Double stage means we put a DC-DC converter and then inverter. So double stage means DC-DC converter people were very happy. But you know what we are going to add another converter. Cost of it, size of it, weight of it, losses of it. Then who will accept this technology? And I told my research student, you have to prove that double stage better than single stage. It was more tough for them to. Research is always reverse now. Research, you have to research into it. And we are able to prove it, and you believe or not, after 10 years industry they were ready to accept it. Otherwise they were not ready to accept it like now. Professor Sudhi is, I think now really in dynamics, so I have to also finish it. Okay, maybe few minutes I will take. Okay. So grid tied I can. So I ask my student to work basically on control of it. Okay. Typically. So a lot of control we already gone to for this application. So I told this here is your solar inverter put to the grid now as a single stage. This is single stage type. Okay, we modify a little bit of it, but not too much. So I want this is a modification student have done little bit of it, and power quality improvement also along with the typical, but not that. I asked the student if there is another load is connected. No? In wherever you are connected to the grid, there will be some load nearby, like rooftop. Home load is there. So after fitting the home load, you should put to the grid. But whatever power quality your local load have, that also you really compensate using this converter. And in the night, you use it for reactive power generation, if it is a single phase, or harmonics also in addition to that. But if it is a three-phase system, you can do the load balancing also, and you can do neutral current compensation also. So you can do additional features of this using this inverters of solar for additional tasks. So this is still single stage, and students have to put good control into, otherwise they will not publish. Okay? And they have to say this control is better than previous control. That's a different reason. I'm not going to really talk about too much about it. So these are my students work out with the better control into it. And then we are going to do the double stage system. What is the benefit? We have to show the benefit of it. That two-stage system is better than, and we are able to prove it. If you put a two-stage, this first stage is responsible for MPPT. Are able to follow like. And second stage is to convert your DC into AC. But my student found it that in DC link voltage and AC side voltage there is a relation to reduce the losses in inverter. And they found a one ratio on which the losses in inverter are reduced around to 4 to 5%. And losses in DC-DC converter we are able to reduce operating on little higher frequency, and with the proper selection of the panel rating, voltage rating, only to reduce the losses around 1%, which I verified in industry in Italy also, that DC-DC converter takes 1% losses. But if we are able to reduce the losses 4% into the inverter, the overall losses are reduced from 3% into it. Means we got a 3% more than it. In spite of two stages, which is able to give a payback very well to that. And then we compensation the load also into this, and it worked very well. You can see even load compensation we provided it, and it would really reduce the power factor correction on grid side also. And even another key problem is the voltage fluctuate, there's a losses reduction into it. I hope I might have result something corresponding to that. I will just show some slide. So same thing we extended for three phase, but three phase, in addition to the reactive power generation, harmonic generation, we have a unbalanced load also. So negative sequence current also have to be generated by this inverter. And this system, when it is put with the DG set, we got one more features. If we are putting an inverter at unity power factor, putting to DG set, the load is there. Load, you might have an unbalanced load, non-linear load. DG set power generation will reduce it because major power generation will come from solar. Now what DG set have to produce it? Only it has to generate the harmonics and reactive power and negative sequence current. So your voltage will be distorted at DC set terminal. Why? Because synchronous impedance of DC set is quite high. Only fundamental AVR can regulate the fundamental voltage, but you cannot really compensate for harmonic distortion. You cannot compensate for unbalanced load current, which gives unbalanced voltage also at the point of common coupling. But if we modify the inverter that DC set currents are made sinusoidal and unity power factor, the remaining that inverter is supposed to generate the harmonic reactive power, negative sequence current line. So we modified, and this my institute engineer who just completing PhD with me, he got this problem because we have a 1 megawatt DG and we have a 1 megawatt solar also along with it. And we are not able to commit the 1 megawatt load. So DG set we never want to overload. The load was probably 700 kilowatt or something like that. So in that case, if solar generation was around 700 kilowatt, DG set is supposed not to give any power or reactive power, only harmonics and reactive power. So there he found a typical problem that some load are slipping because of the probably voltage distortion and voltage unbalance. Then he looked into that, this problem is a good problem really for the research to look into of DG set. So other column also we look at carefully. So this is for 3-phase, we extended it here typically, and then we extended for double stage system also. And you can see typically, I think some students have demonstrated that a voltage typically in grid also voltage distortion is there. Then of course all load variation, other things we took out in this, and voltage variation also. This is the features which I talk about optimum voltage. If you vary the DC link voltage in coordination with the AC voltage, you can improve the current profile, grid current profile. You can say if it is a fixed DC link voltage, the left side, and grid voltage is optimized, then right side. That's about the quality of current, and which is explained there in many of our publications. And then this is the saving. If you have a single stage, then this is the, if constant voltage, then this is the, let's say the losses of generation. But if you have a typically black is, if you have a fixed DC link voltage. So this was the extra generation, and if India, we have a more the low voltage problem. If it is a more low voltage, we get more the extra generation form. So this was the observation for two-stage system, which industry really later on translated into other way. Then when they came to me, I told this is a problem. They say, how you really know about it? We are working for 15-20 years in this. So whatever problem you will tell, it's just like not very difficult to really find out what, only that you are going to distributed kind of things. And they say you can have extra generation. So even two-stage system is proven that you have 3% more extra generation here compared to the single-stage system also. So then we work out all these features with three-wire system. Then we extended to solar water pumping system, typically. And with this project we did good. These are the earlier means of water pumping, and you can see how really number of pumps were installed earlier. Typically, up in 91 to probably up to 2016 was 31,472, and this is the data 14 to 71.1 lakh, and 91 to 2014 it was 11,600, and now every year we have probably more than 5 to 10 lakh pumps every year now. And this is government, all government is putting the money, whether Maharashtra, Gujarat, probably it has not come to many states still like. Industry, that industry is hardly overloaded by the order, not Indian, but virtually overseas orders also that. So, many applications of solar pumping system, not only that. So we work out with this. So what we work out with all earlier people were using a PM-DC model in 91, 92. I went to CL, they were using PM-DC model. Three manufacturers, Clockser Brothers, BHL, and one more industry, Central. These were the three manufacturers for permanent brush DC motor, because they don't want to put any converter into it, directly panel to motor. But that has a brushes and maintenance problem, and you cannot take in a submersible. So we work out all the 5 motors, induction motor, then your permanent brushless DC motor, then synchronous reluctance motor, reluctance motor, as well as PMSM. All 5 motors we work out. It's a very simple formula. 5 motors, 5 PLC strings. Okay? There is no problem. And these are the 5 only brushless motors. Okay? So first they work only on the control. Second stage they really design the motor also, go to industry manufactures motor, and then we really control it. And I tell you interestingly, even in induction motor, if it is operated by the inverter, we are able to increase efficiency. I told one of students who are working in ABB, He was working for part-time around 8 to 10 years. I told you can't do anything because you have a too much pressure. Better you bring it a 1 horsepower, 2 horsepower, 3 horsepower motor, standard motor, best efficiency motor, and the copper bar best efficiency motor. So 9 motor you bring it, your PhD is complete. I'll ask my other student to help you out. And believe or not, even 1 HP we got a specific margin that 74% was the efficiency of standard 1 horsepower motor, 3-phase motor. When we optimize it, gone to 84. With the aluminum bar, with copper bar it gone to 87%. So you can understand 74 to 87% efficiency, 13% increase in efficiency will reduce the panel size 15%. The overall cost of the product is get reduced. Because panel is the most costly product into it, no? Into solar pumping. So if you reduce the panel itself of 15 to 20% rating, the overall cost of your product will reduce it. Like that's why I'm talking about induction motors. Okay, BLDC if you take it, probably it can have a 1 horsepower 95% efficiency. So 74 to 95% efficiency typically you can understand 21% increase in efficiency, which will cause around 25% reduction in solar panel size. And where the BLDC may be more successful for drinking water supply. Half HP motor, probably in place of induction motor of half HP, it can be probably 200 watt. BLDC may be enough for that. Typically. So every motor have its own typical application. Even for simple water pumping, synchronous reluctance motor by ABB is replacing the induction motor. So it has a 4% efficiency, better rotor copper losses are. Rotor losses are completely eliminated in synchronous reluctance motor. And that was the offshoot of a PM synchronous motor for electric vehicle. This motor is now taken only, not a permanent into it, only the synchronous reluctance part only, which is the motor with flux barrier today for synchronous reluctance, which we got it developed by the industry. So we work out with the control of it, with sensor and without sensors also. And you can't put the sensors into the submersible pump 100 feet down or 200 feet down. So we have to go sensorless algorithms on. And some of my students, I told you, not supposed to put any other sensor except on solar panel. You are putting a voltage sensor and current sensor for solar panel, that should be enough to run the entire control, even director control or vector control of induction motor also. No additional sensor, okay? Typically, so, and these are the all 5 motors which are manufactured by Shakti-Pump. All 5 PhD students have gone, every student, because they will not unnecessarily fight each other. Every motor is separate, every control is separate for. So we work out for all, and these are the typically example of water pumping for different, and they are able to successfully operate. And believe or not, induction motor we tie scalar control, we tie vector control, we run, even do research with sensorless reduction, even in direct torque control also. Typically, all these typically we work out for induction motor, then similarly we have gone for, and different model as industry gave a feedback, they say we have to run this pump standalone also. We have to integrate with the grid also, okay? And not only grid, you have to put a small inverter also along with in remote place. Because in the, there are some places in the daytime you are putting a pump house, there may not be a light there, so you have to provide light also from the solar panel only. Like. So a small inverter with this product like that. So we work out all 5 motors typically with this control, and then grid interface also. If extra power is generation, it should go to the grid. Because all the time you may not need pumping. Let's say rainy season you don't need pumping, but you have to already install the solar panel. So it can work as a solar grid interface directly. And when this industry person came to me, he's a BCom guy. You know, sir, if 100 pumps are working and grid fails, can it work as a microgrid? I was really feeling shy to him. You know why? We don't know microgrid. He understands microgrid much better than us. He's able to make the microgrid with the pumps. We never think about making a microgrid even pump that is at all. Typically, maybe, probably even a solar and all that. And he said that, sir, whether I don't think you need the battery into it. Right? You may not need the battery because some places may not be doing the pumping. It may be enough solar generation that can use probably for controlling the frequency and voltage also. So that's the reason we consider this product also, that we can put the power, remaining power or extra. If you put a panel size higher, pump size rating low, generation is higher, you can put to the grid. In when pumping is not required, you can put the power to the grid like this. Because we were having the experience of that also. So putting into this, that didn't took a time much to really look into with the modifying the control. So there are several modes, typically 4 modes, only solar, only grid, PV and grid, okay, and when grid is putting, solar is putting power to the grid. So all modes we operated successfully, of course in laboratory environment, but Now industry is already start putting into the field like the same technology. So we work out all 5 BLDC also, and then we work out typically with the switch reluctance motor also. Like typically we have around almost a dozen of switch reluctance motor with us in the laboratory, and then typically like apart from then we work out with the PMSM, combined synchronous motor also. We have probably around 6. So this is the what we call it you can call it a flux barrier in which you put the magnet, and it got very good synchronous reluctance motor also typically. So that's the so we put like later on synchronous reluctance also, which ABB already manufacturing for EV, for water pumping, not for solar, only to really for dairy and all that, milk processing plant and all that. And they are saying it give a better efficiency than induction motor like. So we work out for all these 5 motors, and all 5 motors Shakti Pump manufacturer. Our student brought into the lab. We have of course industrial commercial motors already we purchased it, okay, from different industry, but it worked very well for all the modes. This also. So that's about the water pumping. That's what we really did through 10 PhD students. Then another application is for EV charging. Are you able to follow like? So you have worldwide people start for putting for charging not only the solar even wind also. Typically, I asked one of my students around decade before, why in the village after 10 years or 20 years, lot of 2-wheeler, 3-wheeler will come. We should have a charging responsibility with them also. So we should have mainly on the solar, but we may have a grid, and you cannot say today solar is not there, grid is also not there, then we will not charge your 2-wheeler, 3-wheeler, then we must have a small disease set also. So we put all, but interesting came, he wrote probably maybe 15 to 20 paper, not a single paper written back. Your concept was there, a synchronization, a concept value was there, okay, we consider only rural application. Typically, very far remote application. And extra generation is there you give to home also, nearby locality also, like a small market or a small, probably, I will not say mall because in village there is not supposed to be mall, but a small village, a small place, maybe there where maybe you might have a floor mill, you might have a water pump, you might have a village, so you can give extra generation to them also. So we consider this as a single phase, and then we extended this also for 3 phase. 3 phase also, the concept was the synchronization into B2K, solid state synchronization. My student, my component supplier, in spite I consider took a 100 inverter of 25 kV, and they operate only 5 kV, in the laboratory environment, 5 to 10 kV, not more than that. But the component supplier says, sir, in 5 years your lab have a IGBT of 12 lakhs spare component. I say, these students are doing, I don't mind, I have money in crores, but at least they are doing, So they will learn certainly, if they damage something, they will learn out of it. But I told the student, if something is damaged, don't worry. Kindly report quickly and discuss with me why it is damaged. Probably I can give you better experience why it is damaged. And say more the why the synchronization, and apart from what was the another is one device of 3-phase inverter, they are making boost converter. So both devices are run series, so it comes as a reflection on the cinema, and the voltage, capacitor voltage plus the input voltage is go to probably in place of 700 go to 1200, device was 1300 volt and device blow over. So I have to analyze sitting with them without going into the lab and to understand why they are running. And I told constantly that tomorrow don't commit such experiment, okay. But please be cautious a little bit. I don't want you to make a circuit yourself, but operate a little carefully. I don't mind you operate a little lower voltage also, and then see the higher voltage coming across it. You work out, let's say 230 volt, but 1200 volt will not go. 800, 700 volt device will not have blown out, like something like that. So we work out with this, and for this charging infrastructure, and with this I would like to convert. And thank you, Professor. So back to you. These are our some publications, probably what have, I don't know, maybe 1,000 publications on solar total. Around 1/3 publication may be there on conference and journal. Might be around 50 patent also. On this solar and its applications, special applications. So that's the reason I thought you should share with you. Okay. If you have any doubt, I can tell you, but I can't make you expert in probably half an hour or something like that. Okay. If really you are doing something, if you have some doubt or question, I will be happy to answer it.
Sir, I have a question.
You can speak, no problem.
Sir, with so much of microgrid coming into the picture, What is the future of power transmission business? Will it go away?
You are going to make me my enemy here? Everything, it is India. The requirement is huge. Everything will remain here. Okay? Okay, power sector will be there, microgrid will be also there. You know, requirement of 140 crore people, and you want to get them developed country India, where you will require at least 20% more, 20 times the more power. You know, what is our power consumption, you know, at the moment per capita?
Around 2000.
2000 units.
Yeah.
Where the North American have 25,000 units.
Yeah.
So this is 15% more. So even if you generate 20 times, still it will be solved. We have a 500 gigawatt generation, na? So if you go even 100,000 gigawatt, still electricity will be solved to get developed country. I don't want to follow like him. So all kind of system will remain there, don't worry. Okay? Otherwise you will make it there enemy. I mean, still you know the wind and hydro have to go through the transmission system, and solar also have to go. Because you know, I mean, I was interested. As well as solar.
Yeah, hybrid parks are there.
No, it's all connected to the grid. There is no question of hybrid, you can call it. All connected to the grid. And more challenge was that he showed me video, their engineer, that when the wind turbine is moving, the shadow is coming on the solar panel. We consider the solar panel, sunlight reflection will not change very quickly. Your intensity will not change so quickly. He showed, sir, it is changing very quickly. Because when the blade because our power electronics engineer and the solar engineers, they never sit together. We are using 25% energy into it. And we talk about, yes, you can have a 15 to 20% more generation, but they say, sir, this concept is applicable to cell level also. You not to do only on module level. Okay? So now we put a DC-DC converter with every module and do a maximum power generation from every module. One might be generating 50%, other might be generating 100%, maybe some is generating 75% or 20%, 10%. But still they will generate maximum. So this difference, if one is 10%, it reduces to 10% to all the module. So module problem is okay. Now every module they have again 60 to 70 cells. Now they say, can you put this DC-DC converter into cell level? This is not our job. This is probably the microelectronics people and physics people, those who are really, making the model, that is their job. So that DC-DC converter into cell level itself. So that may also probably make you again, probably 10 to 15% more power generation. And this is something your power electronics. 10 to 15% here, 10 to 15% here. And that will come, you can understand, around 25% more generation from same existing panel. I don't follow like how provided the power electronics engineer get interface together. So most of the scientists who are really involved into the research of cell and model. But nobody is looking into research. Now there is a requirement, people start looking research into it. I don't follow like especially. So there is a big scope of research further. I put the, I am now outgoing person from this research, but I can identify the problems. Like I can understand how the development can further go into it. And technology does not mean the cost. It will not increase if I am able to generate 15% to 100%, 7 times more power from the same area, cost is not going to increase too much. I can tell you, it will not be 7 to 8 times the cost increase. I hope partially I am able to convince you. Okay, any other question? But there is a lot of, I have not put probably till our Ayodhya temple inaugurated, and afternoon Prime Minister declared it, we have to put 1 crore panel, rooftop. I have not put any hand for startup in solar. Because the people like sitting into this, politicians sitting like that, the electricity is free. What policy will make it into it if it is free? I don't follow. When Prime Minister declared it that we have to give a subsidy, we have to accelerate, then I thought there is chances of startup into it also. But I given an idea to start up something different, like nobody appreciates electricity, do something additional with it. Okay, like a pump, 200 watt submersible pump, okay, or put like a 2 induction cooker with like a replacement of Ujjwala Yojana. You have a 5 crore Ujjwala Yojana cylinder which you are giving a free of cost panel. So I mean the cylinder side, and you are going to take import gas and then putting them. In place I have probably the panel of 3 kilowatt, and probably it may easily support to your induction cooker. It can support 4 fan, it can support 10 lights. If it is the isolated system, put a battery into it, maybe light DC battery, which is never go for more than its application less than 10 years. Okay? So, or if it is a grid connected, there is no problem. Okay? Typically. But the people not understand typically the electricity generation. They will appreciate if you replace the cylinders, gas cylinders. Okay? The government is, election are gone only to do the gas cylinder price 100 rupee, only reduction of it. So here, I mean, if you really proper government adopt it and replace the 5 crore cylinder by solar generation, electricity generation by this, and making a very clean environment, no? Like an induction cooker, not need the light or nothing else you need it, no smoke, nothing is. Okay, because that is a very extreme technology if you go to developed country like a hot plate. Go to North America, you go to Europe, you will not find probably the gas cylinder, no? You will find only hot plate there. You put only hot plate with this solar generation, I mean, probably that will serve the purpose. And 300, because if you put 3 kilowatt, how much is generation it will do typically? 15 units in a day. 15 units is more than enough for electricity for people of at least 5-6 people living in a home. Like typically. 50 units a month is enough. If it is a grid connected system, you can use the grid as a battery. Okay? There is no problem like that typically. So there is a lot of scope of developing. I told you, okay, make a replacement of this your Ujjwala Yojana. One can manufacture the battery, one can manufacture MPPT controller, one can manufacture induction cooker, one can manufacture pump, one can manufacture lighting system, one can manufacture the fan. It will come 5 to 6 startup and one will assemble. Problem will be only those. The hero cycle which was made in Ludhiana, one make a bell, another make pedal, somebody makes chain, somebody make a tire, somebody makes a spoke. How many startup company were there? We are not giving name to them startup. They work with very low margin, but their market is very assured. They are not going to sell into the tire into the market. They are giving only to hero cycle manufacturing. So you can have even in this also around 8 to 10 startups. And 5 crore is not a less number product required in the country. And day by day it will increase more, and government burden will reduce it. If you develop a right product, Prime Minister will be happy to inaugurate. If you make them to politicians to make really to understand properly, yes, this is the burden, you are going to reduce it on government. Typically like. So no question? I think, Professor Sood, back to you. We can have, I will be there on lunch also if you want to discuss something. Your Indians are very feel shy to talk, no? But they have something in heart. So if you have to discuss something, you can. Okay, no problem.
Thank you, sir. Thank you for your talk.
Thank you, sir, for very nice lecture, full of practical knowledge, and it has gained increased my knowledge. I think all the participants must have added some quantum of energy, quantum of knowledge to their knowledge. And so, I'm thankful to all of you for listening very carefully, and thank you, sir.
Thank you, sir. Thank you for ending the session. Now I request Professor Vayasun sir to kindly felicitate Professor Beam Singh sir and kindly give him a token of our appreciation.
अरे ले आओ यार कैमरा वाला जल्दी ले आओ यार मोबाइल से ही चलेंगे तो बोलता यार मुझे गर्दन हिला रहे हो गया ना ठीक है तो ले लो
Thank you, sir. I now request our conference chairman, organizing chairman, Professor Dr. Anivas Maya sir, to felicitate Vayasun sir. Please give a round of applause to our second chair. Thank you everyone for attending the keynote session. Now I request all the faculty members and the guests to proceed to Institute Guest House for the lunch. Thank you. Students and participants may kindly go to the Satpura Guest House. An electric vehicle is arranged for you outside, so you can use it. Thank you. Faculty, please proceed towards Institute Guest House. Thank you. Thank you everyone.